Hello to everyone. Thank you for being here. I know that it's not the best slot for the talk after the lunch. So a quick who am I? My name is Alberto, as he mentioned. I'm also known as Bubu in the security community and CTF. I'm mostly interested in web security and privacy, also on browser internals. I'm a CTF player for a couple of teams. Maybe the team that you might know is the Hackers Crew. I'm also an invited expert of the W3C Security Interest Group. So this is just a slide for a sort out for root me and the Threads community. So this is like a part of how I started. So just a sort out for them. So I'll be talking about browser permissions. Just a bit of disclaimer, I'm not going to talk about Android, mostly it's only browser in the desktop. So as you might know, there are a couple of permissions in the browser, like geolocation, camera, microphone, display capture, USB, clipboard, and a lot of people use these kind of services daily, even our mom or parents or friends, and they are not really into computer security. So how this works? There are around 80 permissions, more than 80 permissions. There is no up-to-date list. Some of them are like really popular, like camera, display capture, but there are also others like local network access. That is a permission in which the website can access the local network if you don't allow it. So this is an open source tool that I developed, and is like open source tool and also the website, and is a list of the different permissions that are supported by the different browsers. So you have like all the Chromium-based browser, also Firefox. So maybe this is the most up-to-date list. There are two main characteristics on permissions. The first one is if it's powerful. If it's powerful, only means that there will appear a pop-up to the user, like the usual camera that appears a pop-up, and the user needs to explicitly grant or deny the permission. And the other one is if it's policy control. In the case that if it's policy control, it will have a default allow list. That only means that, for example, on self, only the top level document will be allowed for using the permission if there is no delegation. So not every policy control feature, not every policy control permission is powerful, and not all the powerful permissions are policy control. Most of them, they are both of them, they are policy control and powerful, or only policy control. Apart from these two main characteristics, there are individual specs for each of the features. For example, for camera and microphone, there is this media capture and streams. And on this specification, apart from declaring a lot of stuff, they usually have two sections. One is talking about if they are powerful, and the other one is if they are policy control. These screenshots are from the media capture and stream, and you can see that there are a definition of two permissions, camera and microphone. And for the policy control section, there is also the default allow list. At this point, how a developer can restrict access to the permission. Like, for example, my website is not using any of the permission. How I say to the browser that my website doesn't use permission, and not iframes and not third-party scripts can try to trick the user. There is a header that is an HTTP response header that was formerly known as feature policy, but got rebranded in 2021. Also, the syntax changed. And in the case of permissions policy header, it's really simple. It's like on the example, maybe it's a bit small, but is camera equal to empty parentheses, and that means that on your website you are not going to use, and the scripts can ask for the camera. So just to be on the same page, I had like a couple of examples. Let's say that there is a permissions policy header that, as I mentioned, is for restricting the permission. And then on the right, there is an allow tag. Allow tag, HTML allow tag, is for doing the delegation to other contexts. So on the header, we have camera to empty parentheses, clipboard read to self, and clipboard read to self and iframe.org. The website includes an iframe with a source iframe.org and the delegation. So in this case, the camera won't be allowed in any of the context. Clipboard read will only be allowed because of the permissions policy header on the website, on the top level document. And the clipboard write will be allowed in both, on the website and also on the iframe. If we change the iframe source to second iframe.org, this won't be allowed to use or ask for any of them because of the permissions policy header. The website that I saw before, also has like a part on it in which you can create your own permissions policy header, because in a research that we did, that we'll talk about later, that for developers, even that it looks simple, for developers it's also hard for declaring this header. Like we saw like thousands of websites using like ending the permissions policy header with a comma, and that is a misplaced comma, and for the browser will be the same as not declaring the header. We also saw that some websites declare contradictory directives like self and wildcard. So this tool that is also open source allows developers to declare their own header. Now we are getting to the funny part, or the hacking part. There are a couple misconceptions in the community. The first one is controlling delegation versus same origin policy. So in the moment that the permission is delegated to a context that you don't control, that you lose the control of that permission. So in the example on the right, there is foo.bar that has not iframe.org and iframe.org. In the moment that the permission is delegated to iframe.org, iframe.org can delegate the permission to not iframe.org, even that you have on your permissions policy header, only iframe.org can access or try to access the permission. These misconceptions are going to be important for the rest of the talk. The second one is the misleading prompt. So you visit like foo.bar, and foo.bar has a widget that is from the origin meetexample.org. And if meetexample.org tries to access these permissions, on the pop-up that will appear to the user, it will only mention the visited website. In this case, foo.bar. This can trick like the user clicking or granting the access. The last one is that there is no reprom. In the moment that you grant the permission to the website, and let's say that later an iframe is included, that iframe can access the permission without a reprom. So with this like permission model, I'm going to explain two thread model that can happen on this permission model. The first one, in which I found vulnerabilities in two big popular software. So on this first one, the idea is to hack embedded documents that have permission delegation. In the example of the slide, there is BubuChat that is included in different couple of websites like news, weather, a bank, and so on. And it's a really popular widget that always has a delegation of 3 important features, like camera, microphone, and display capture. So the idea here is to, instead of hacking each of the websites, to hack BubuChat in order to do this second delegation to do a permission hijacking. So the idea is to insert this second iframe just by hacking BubuChat. How I found like potential candidates or how I found that this theoretical attack could be like real. This research was part of an academic research that was published this year at IMC 25. On this research, we did a measurement of how websites use the permissions, how they delegate the permission, even how developers declare the permissions policy header, and we found that there are some of them, some iframes, that they always delegate permission, but they don't always use this permission. And from these kind of iframes, we found that there is one category that is customer support widgets or chat widgets that they usually are included with camera, microphone, and display capture. So that's how I found like these candidates. So customer support widgets usually appear in the corner with an icon, and if you click it, it will open a chat in which you can talk with the worker of the company for asking questions, and the worker will reply. These chats are really common, are really widespread, even in banks, so it's not like some edgy case. And for the companies, it's like a really good solution for having all the questions from the customers in just one place, for knowing also some information from the customer, like sometimes the location, the email, and so on. So it's like a good software solution for the companies. In the first case that I found a vulnerability for doing this second delegation and for doing permission hijacking was glasses. Glasses, depending on the statistics, it is included in 100 websites, but if you take like whole internet, it can go to almost 2,000. On this one, as an attacker, I just tried using the software. I sent like a couple of messages, and usually in this kind of software is useful for having like an attachment, like documents that you can send to the worker, like for example, proof of a payment that you did, or a screenshot or something. And I found that there was a type field on these attachments. As an attacker, I just tried changing this type, and I found that you can insert more things that what they will expect. So you can set like audio, video, and there was one of them that was including like a website inside the chat, like an iframe with the type 8. So you could insert like this document, and the worker would load this website. Don't know if you know, but there are local scheme documents. I'm going to talk a lot about local scheme documents, so they will be important for the rest of the talk also. These are headerless documents, so there is like no request out and no response. There are no headers. And it's called local scheme documents that they are running in the same origin in which they are embedded. So I use like this for inserting my JavaScript, but for the case of classes, they were using CSP, Content Security Policy. Don't know how many of you know CSP. CSP, or Content Security Policy, is a response header for like an allow list of resources that the browser can load. So if your script is not in this allow list, it won't execute, so you won't have the cross-site scripting. But as you can see, this one was really big. And there are many community tools to find if there is some of these endpoints that you can use for your cross-site scripting. So I just use one community tool that is called CSP Bypass. And the idea was to include one script that is allowed, like the one from reCAPTCHA. And this one will take a custom event that in a normal HTML browser won't execute, like ng on error, but loading this script will allow bypassing the policy. So at this point, I have like a cross-site scripting on the side of the worker. So just by sending a message, I can do a cross-site scripting on the other end. Assuming, because my idea wasn't like to be an expert of this specific software or classes, I just assume that the person that was reviewing the chat had also some admin privileges to change their own widget. So, as I said, at this point, just sending a message, I can have cross-site scripting on the other end. So let's move on to the second part, that is including our code into their chat widget of the company. So I just went directly to customizing the chat widget. Usually this kind of widget have some fields that you can change, the color, the icon, the photos, and so on. But for this case, there was a specific field that was embedded apps, in which you could insert like your own website inside the iframe that they have. So as you might think, I also use local schemes for doing this second delegation. So with this second delegation, we have like the complete exploit, like for doing this second delegation and doing permission hijacking. So a small recap, just collecting all the companies that use classes, you send them this payload with the type 8 using the local scheme. And with this, for the cases in which the person who is reviewing the chat has also access for these embedded apps, you could insert your iframe in their company iframe, doing this second delegation. And with this, you can, from your document, ask for the permissions of camera, display capture, clipboard read, and so on. And because of the misconception that I explained in the beginning, the user can trick granting the access to this permission. So I just did a small proof of context that this was working. I used the first part of the payload, and I got a ping back. This is not an IP from Spain. So it just was for knowing that it was working. I reported on May, a couple of days, 1 day later the reply, and 2 days later they applied a fix. Let's move on to this one, to live chat. That is one of the most common chat widgets that there is out there. Depending on the statistics, it can go from 38,000 websites, but if you check like in the whole internet in Buildwidth, it can go, it is embedded in almost 500,000 pages. This one, as you might think, it was a bit harder. So just a bit of technical information before starting. Live chat uses two iframes. The first one, that there is no source, so it's same origin as the website. When it's minimized, and when you click it, like it does the delegation, and it also allows the source to live chat. So on this one was a bit harder. I tried like the same approach, digging into the chat. There wasn't anything useful. And then like I moved to the admin panel. And on the admin panel, I saw that there was an iframe of the marketplace. Usually this kind of software has this marketplace for adding like more stuff, more functionality into your widgets. And at the beginning was like, okay, they are doing an iframe of the marketplace, and I started like checking the marketplace. They can add like plugins from WhatsApp, Telegram, and so on. I saw that there was a comment section, like in any kind of marketplace, but this one was a bit special. They were using like Markdown in the comment section. Why would you want to use like Markdown in the comment section? So at that moment, I thought that this is like my entry point. I checked which library they were using. They were using one that is called Markdown to JX, and I saw that there were a couple of issues in all versions. Also, on the README, there was no mention to security, so it was like a good starting point. I found that using content editable, this is the first thing that I found, that using content editable, you can break the website. This one wasn't because of the library, it was how they include the library. A second one was a meta redirect, so you could redirect any of the plugin websites to your own website. The third one, it was an style injection. You can like change the color of your name or the color of the page and so on. So just by creating an account, you could do all this stuff, like doing the redirection, maybe for phishing. You could make like the marketplace inaccessible. Let's say that you develop some plugin and you want to be like the best plugin in the marketplace. Or the third one, you can change the style of the page because there wasn't like anything useful on that page. But finally, I found one way of doing the cross-site scripting. It was a one-click cross-site scripting using button for action. But this is even worse when you can also change the style of the page. So you could make like the button in all over the screen, like invisible, or you could put the button in the same place as the installation button. So it's one click, but there are ways of being like easy for the admin to click it. At that point, I thought maybe they are using a different token for the marketplace, because remember that we are on an iframe, or that is a different origin. Maybe they are using like a token that can only install and remove plugins, but this one wasn't the case. So the same access token that they had on the marketplace is the one that you use in the dashboard. So you have like the same privileges. So here, like we just need to create an account, and we can comment in all the plugins on the marketplace. And when an admin like loads this page from iframe or just visiting the marketplace, it will appear like this invisible button or the button in the top, in which if the admin clicks, it will be an account takeover, or what are we trying to do the permission hijacking. So let's move on to the second part. Same as before, the first thing that I checked was the chat widget customization. All parameters were sanitized, like changing the color, the position, and so on. All parameters were sanitized except one. And for us as an attacker, we only care about having one entry point. So just a recap, this is like the full chain. You just need to create an account, comment in all the plugins, and wait to admin person visiting the marketplace and clicking somewhere. At that point, you have like the same permission as that person, and you have an injection. And the thing here is that the injection wasn't on the different origin iframe. It was on the same origin iframe, that is when it's minimized. So you have like a cross-site scripting or an HTML injection on the website of the company. So I reported this last year. A couple of days later, they replied, and 10 days later, they applied a fix. Now we are moving to the second part. For this one, I don't have like any vulnerability, and it's for the websites that use a permission for the service, like for example Meet or Zoom, or for example the websites that allows you to change the configuration of your keyboard. So for these cases, if they don't declare the permissions policy header, maybe you can do an HTML injection for delegating the permission to your domain. So let's say that you are on a meeting and you granted like the camera, the microphone, display capture. In these cases, it's even worse because you can have granted the permission, but you turn it off with some button on the website, but the permission is still granted. So you can still delegate the permission and do the permission hijacking. So for these cases, even if they have like a really CSP that you can convert this into cross-site scripting, you could, with an HTML injection, if you find some HTML injection on this kind of websites that use the permission, you could delegate these permissions to your domain. And for this one, it's not even important the misconception, because you will be allowed to use the permissions without doing any reprompt. So the only solution that they have is like declaring a strong permissions policy header to a directive cells, like for example, for Meet, using camera itself. It's true that most of the websites, they don't declare permissions policy header. But the idea will be that if they declare permissions policy header, they will be like safe. But this is not true. local schemes like attack again, strike again. If there is a website that has a policy of camera self, and there is like a delegation to a local scheme, if there is a delegation from this local scheme to to attacker, the idea will be that this local scheme, because they are headerless, they have to inherit the policies from the father, from the document in which they are embedded. Like, for example, it happens with CSP. But this is not really true right now. It's a bug that I found last year, and it still works in all the Chromium-based browsers, in Chromium, in Chrome, and all of them. So even if there is a camera self header, you could use a local scheme to avoid this policy. And this is all. I have like 3 words. The first one on the left is like the academic paper in which we did like the top 1 million measurement. The second one is a blog post of how all this stuff works, because I can explain it in 20 minutes. So I recommend reading it. It's short. And also this one, it also appeared on the page out scene. So I think all of you got one printed version, so you can read it there. And the last one, maybe like for a warm-up for tomorrow's CTF, I designed a challenge for the CreCTF that was this year. It was a 48 hours, and only 15 found the solution. So if you want to try it, there it is. And that's all from my side.